All right, everyone. Hopefully, you gave this a shot, that you found the z-score that goes with number 7. You found the probability less than, and if you can make sense of the 200 calls, then you are really doing well. Hopefully, I'm hoping that everybody could get the probability. Let's read it and do it all together. The San Diego Police Department reports that the average time to respond to a 911 emergency call is 11.3 minutes. These times are normally distributed with a standard deviation of 4.4 minutes. If 200 calls are randomly selected, how many will have a response time of less than 8 minutes? Okay, first up, let's find our z-score. And I'm just going to show this whole thing, right? So they tell us the average, they tell us the standard deviation. In the end, when they ask about 8 minutes, that's got to be our x. That's the number of minutes in question. And so we will put all of those in and get a z-score. Comes out pretty clean, actually, negative 0.75. Turns out you didn't have to round that one. It is what it is. Okay, so there's your z-score. Let's find the probability. And they do phrase it as less than 8 minutes. So the probability that capital Z is less than our little z, negative 0.75. If you are using your table, then hopefully you arrived at 0.2266. I'm looking for my table at the moment. I did something with it here, I guess. So what's the 200 calls all about? I cannot find my Z table. Well, we'll see how it goes. I think I gave it away. What is the, so once we have that, okay, so if they're asking about, that's the probability. So if they're then asking about 200 randomly selected calls, what we'll do is multiply our probability by 200, and we end up with, you can see it right there, 45.32 calls. You could answer that way, or maybe you round that to just 45 calls. Either one makes sense. Either one makes sense. Okay. Number 8. Keep moving along. Maybe my Z table is, there it is. There it is. Okay. I might need that. Let's read number 8. The miles per gallon of gasoline, usually we say MPG, miles per gallon, for a new model car is normally distributed with a standard deviation of 4.5 mpg. Also, only 12.1% of new cars get less than 20 miles per gallon of these new cars. What is the mean miles per gallon of a new car? Okay. This one, they're really switching things up. They're not asking for a probability, right? They actually give us a percentage as part of the problem. They're asking for the mean. So turns out there's kind of a backwards working here. We're not going to be told x mu sigma and calculate z. We're looking for mu. We're going to use the same formula, but it turns out we're going to have values for the x, value for sigma, a value for z, and we're going to be able to solve this for mu once we have these other 3 numbers. Some of them are going to be pretty much just given to us. One of them, the z, we're going to have to do a little work. Okay, so here's what's going on. Let me just reveal all of this. So as we read the problem, okay, it says, the standard deviation, 4.5. So, okay, right away, we know the standard deviation that we're going to plug in. It says something about a percentage of new cars. get less than 20 miles per gallon. So the number of miles per gallon in question is 20. That'll go in for X. The Z, though, is going to take a little bit of work. That's where the 12.1% comes in. It says only 12.1% of new cars get less than 20 miles per gallon. So we don't know the Z-score right now. We know the probability, 12.1%, 0.121. So we're going to have to use our table backwards to get the Z-score. Then we'll plug all of those three numbers in and we'll solve for mu. Hopefully that makes sense. I think what can be confusing is that X is 20 and then the Z we working backwards. But that's how it would have to fit. 12.1% of cars get less than 20. So had we been able to plug that in originally, we would have got a Z-score, looked up the probability, and gotten 0.121. But since we're given this and we got it, okay. I get it. This one's a confusing one. Take your time. Maybe replay that video. Read the question again. Make sense of it. I'm going to continue on. So I'm going to grab my table of Z-scores. I'm going to assume that you guys have yours there. Really encourage you to print it. And I'm going to find 0.121 in the middle of the table. And the first question is, should I be looking at the positive Z-scores, that side, or should I be looking at the negatives? Well, I don't know what you're all thinking. Since our probability is less than 50%, we got to look at the negative Z-scores. So I'm going to try and find 0.121. And sometimes this takes longer than others. Okay, I'm in the 0.12s. 0.121. Ah, there it is. 0.1210 is Z-score negative 1.17. When I work backwards. Now that's really the difficult part of this question, is recognizing I need the X, sigma, and Z, and then I got to solve that, and then realizing these are what they are and work. Okay. Once I have these three, and I'm just going to give the whole thing away now, I'm going to plug in my Z, plug in my X, plug in my sigma. I need to isolate the mu. Well, I can multiply, right? I could add the mu, I could add the 5. In the end, mu equals 25.265. And it's not really a big deal. We have the answer. But if you wanted to know what the units are for the mean, they're always the same as the units for X. In this case, miles per gallon. The average miles per gallon for these types of cars, 25.265. You could also, you could confirm your answer, right? You could take this mu, take your X, take your sigma, plug them all back in, calculate that Z, and then kind of go back and confirm that that really would give the 12.1%, just to see if you did it all right. Okay, there's number 7 and number 8. I think it's a good idea to stop this video here. Turns out practice number 9 is a long one, and it's got 2 parts to it. So I'm going to stop this video. If you want to take a look at number 9, maybe try out part A, then I will invite you to do that. But we're going to do the whole thing in the next video.